Let's look at some day-to-day issues when we're writing code. Here we've got lists of data and we need to align them. So let's look at some ideas for how we're going to address the problem. How do we align two lists of data? Well, here we have two lists, A and B, and we need to find the items that are in both lists A and B. We need to find which items are in both and where are they. So we can start off with the letters that are in both lists are B, C, E and F, and their location in the first list is at 1, 2, 4 and 5. Remember, we start at 0. So we have 0, 1, 2, 3, 4, 5. Those are the indexes. So for example, the first letter that's in both is B, and that's in position 1 in the first list and position 0 in the second list. C is a position 2 and 1. E is a position 4 and 2. And the last one, F, is position 5 and 3. So that's how we would align two lists. So let's have a look at our example in code. We have our two lists, A and B, and we can go through the list using for loops. We're going to use range because we need the index number, here represented by I and J. So we run that, you can see we have our 10214253 answer, which is correct. So we just need to add the code to put those numbers in a pair and those pairs to be put into a list. So we can see our answer of pairs that are in a list. So we can see our code here. Now, items are not always the same. So let's have a look at another example where the items in the list are strings that are not equal. So what do we need to do here to align them? Well, we need to compare each string and find out some type of score, a similarity score. And then once we've got those scores, we can do something with those scores. So how do we compare strings? Well, there are quite a few Python modules, so we can have a look online and we can find the sequence matcher that compares strings. So we can use that in code. So the top part is just code we get from the internet to compare strings. Then we have our two lists, and we can use our two for loops, and instead of matching each item to say are they the same, now we've got a similarity score. So let's have a look at our code again. Now we have our strings in our list, and we're going to copy and paste that code that compares strings. So we call a function called similar rather than checking to see if each item is equal. So we change the code. So we're going to get a score. We're going to call it Z. So Z is going to equal what's similar between the item in A list and the item in the B list. That should be in uppercase B. That's right. So we're using I and J from our for loops like we did before. So this time we're going to have a look at our pair but with a score Z. So that's a bit of a mess. So we're going to look through, we're going to go through, use a for loop, go through each item in the list so it prints a little bit easier to see. So when we print that, you can see that actually we've got quite a lot of comparisons, and most of them are 0. So we've got quite a lot there. So we only really want to see the similarity score when they are similar. So we can say like if Z is greater than a threshold such as 0.3. So now when we enter that, then we take out all the low scores, and now we have more of a useful list of similarity scores. So here's our results so far. We've got the place in the first list, the index, the place in the second list, and then we've got our similarity scores that are above our threshold of 0.3. But when we loop through our list, we don't really need to check every item in the first list with every item in the second list, because when they're aligned they're in a very similar place in the list. Not identical, but similar. So we can move along the list and we can see that each item is likely to be in a similar place until we get to the end of the list. So when we compare them, we don't need to compare every single item in the first list with every single item in the second list. We just need to compare where J is close to I. So let's try first where they are within plus or minus 1. So in this example we have a list with a length of 8 and a second list with a length of 7. So the difference is only 1. So when we align them, we assume the items are either going to be in the identical same place or give or take either side by 1. We have to remember when we're looping through our list and we're looking at the same location, minus 1 and plus 1, we're going to get an error if we go at the end of the list and we go too far, or we're looking before the list. So if we go minus 1, there isn't an item at place minus 1 in the list, and if we go greater than the length of the list we're going to get an error. So we have to watch where we start and end when we go through our loops. So let's go through our code again. Now we're going to look for the items. We want to look in the smaller list, in this case it's B. We're going to use a for loop and we can look in the same place and the place before and after. So we start off with the easy code, which is looking in the same place. So we change our code to look through each item in B, and then we're going to pair that with the item in the same location in the list called A. So here we have the scores that are above our threshold of 0.3. So that looks fine. So now we have to put the right index. So now we have the index of I and I, which is the same, because we're looking in the same place. Now we need to think about minus 1 and plus 1. So we need to think, where do we start our list or looking through our list, and where do we end? So we're going to have to put in if statements to make sure we don't get an error message. So we've got 3 parts of our code. We've got where the item is in the same place, I. We've got the place where is going to be minus 1, so we can say I minus 1, and also later we can say I plus 1. So we have to make sure we're not going to start too early, so we can say if I is greater than the star, then we can compare. So we're not going to compare minus 1 because we get an error message. So now we have a code for the comparison of the item at I, the location in the list B, with the item in list A that's at I minus 1. So we can use, remember we're using a gap of 1, the difference is 1, yeah, which is the difference between the length of A and length of B. So now we can see now items in both lists there. So let's check. We can copy that code, and all we need to change, instead of the minus 1, is the plus 1. We also want to make sure that I is less than the end that we created. So we make sure we've got the plus 1, the minus 1, and we can make sure the lists are the correct lists, and then when we run them we can see that we have a shortened version of similarity scores. Now we tried when there's 1 difference. Now let's try with a difference of 2. So we can change our lists. So the first list has a length of 9, our second list has a length of 7 items, so the difference is 2. So we need to check both lists where the difference might be plus or minus 2. So let's look at our code initially with the same list we had previously. Let's go back to our code. Now this time we can't just use +1 and -1. We don't know how much the difference of the gap is. So we need to use the loop of the smallest list, and also we need an inner loop going through the difference. So for example, -1 the same +1, or -2 -1 the same +1 +2. So we've got the gap, the minus the gap, to the gap, and that range of where we're looking. So instead of just looking at I, we're going to look from I plus j. So j is going to equal -2 -1 0 +1 +2. So we have the minus the gap to the gap plus 1. So that will give us the range that we're looking at. So again, we need to make sure we're not starting at the wrong position. So we can use an if statement. So to start off, we're going to make sure we're not starting at -1. So I plus j has got to be greater than -1. And also I plus j is not going to be too high. So we're going to make sure it's less than the length of the large list. So the rest of our code is the same as before. So let's try this. Let's make sure we check the correct list, the small list, then the large list. We're going to check I plus j. So in the result in pair, we've got I and I plus j index. So now we run that, we have our index of the small list, the large list, and our similarity scores. We can check that to see if it works with a longer list. So we're going to change A, we're just going to add another item. So A is 2 longer than B, the length of the list A is 2 bigger than B. So we're going to have a gap of 2. So we print that to show it, and we're going to run the code to check. You can see the gap is 2, and now we have the correct similarity scores and our code has worked. So let's look at those similarity scores. We've highlighted the highest scores, and when we take them out, we've now got the index from the smallest list and the index from the largest list, where we've aligned the strings with the highest similarity score. So if we put that in a diagram, if we look at the smallest list, we can see that the items in index 1, 2 and 3 match the index of the long list 3, 4 and 5, and the last two items in index 5 and 6 match the last two items 7 and 8. So we can see here how we can align from the small list to the large list. Now obviously the item that's in the index 4 in our small list can go to 5 or 6, but we've already got 5 and 7 either side, so we know that's location 6. So we can determine pretty much all of the alignment places except for the first one, because we have two similarity scores that are the same. So in our short list, the place at 0, we don't know which one it aligns to, but it aligns to either the item in location 1 or 2 in the large list. So if we look at the small list and the large list together, we can see we can align nearly all of the elements except for the first element item in the small list, which goes to places 1 or 2 in the long list. We don't know which one, but that's our alignment according to the similarity score. Okay, if you like the video, please click the like, and if you haven't already, please subscribe. Thank you for watching.